Hello, this is Jerry Fawcett. I'm a Senior Developer Support Engineer here at Synergex. In this video, I will offer some tips on how to create a small test case when submitting an issue to Synergex Support, as opposed to sending your entire large application. Providing development with just the minimum code necessary to reproduce an issue greatly increases the speed in which the cause is found and the issue is resolved, as development can focus on the code that is involved and not have to deal with code that doesn't contribute to the issue. The test case the customer provided was based on the Synergy.net Assembly API, thus had code in Synergy and .NET Assembly. Data definitions were defined in the repository, and environment variables were required to be set to run the application. The application was made up of many separate components. None of this is unusual in a real-world application, but not all of the components are necessary to reproduce the issue. The issue the customer reported is that their application would randomly crash with no apparent pattern to when the problem occurred. The application would work as expected, but eventually, with no difference in the steps performed within the application, would crash. Luckily, a break was made, and we found the cause was that our Cindy would not release the memory it consumed after the application exited, and the excess server connection was disconnected. Thus, after repeated runnings with our Cindy consuming more and more memory, this would lead to a crash of the runtime. However, at this point, we had a large application utilizing the .NET Assembly API, thus a Visual Studio project was involved, repository, include files, and many components which simply were not necessary to reproduce the issue. Now comes the fun part, determining which components of the application actually contribute to the issue and which may be removed. I need to get the application to its simplest form to then submit the issue to development. Submitting minimal code to reproduce an issue makes our job of finding the cause and a resolution much simpler than working with a large application. Thus, I reviewed the code in the application as a whole to determine its functionality. To simplify, I found I could move the Synergy code from the .NET Assembly to the mainline. This one step eliminates the need for a Visual Studio project and the Synergy.NET Assembly API. In many cases, the Synergy code in a .NET Assembly may simply be moved into a Synergy source file. You may have noticed the code was moved as is and needed almost no significant modification. I created a record with the necessary fields, removing the need to supply a repository when submitting the issue. A comparison of the repository structure to the record shows a large percentage of the fields were simply not needed to reproduce the issue and are not included in the record. Set log, the code now creates the necessary environment variables, eliminating the need to provide a script and for running a script as part of the process of reproducing the issue. In the application, I eliminated any code or component not necessary to reproduce the issue. After all the changes, I had a small, simple mainline that would reproduce the issue. Now I'll run the small test program. As you can see by watching the Cindy process's memory usage, the only difference is now the small application's DVR process needs to be killed instead of exited to reproduce the issue. So in conclusion, some of the easiest and most effective ways to create a small test case from your large application are: examine the .includes and remove any that don't contribute to the issue or are necessary to build the application. This step alone may reduce the application greatly. Replace any necessary .includes from the repository with the equivalent data areas to eliminate the need to supply a repository when submitting the test case. Removing the repository eliminates not only the need for the repository files, but setting the environment to point to a repository. Remove any code that is not involved when reproducing the issue. For example, subroutines and functions that don't get called when reproducing the issue. This is another step that may reduce the application greatly, and removing this unused code is a big help when development examines the issue for its cause. Any environment variables that are necessary for running the application within reason or reproducing the issue can be set within the code with setlog, eliminating the need to provide a script to set up the environment when running the application. Any code from external calls, also within reason, can be moved into the mainline. When building the code, create a list file on the compile with the -L option to have in one file all the actual lines that make up the application. Then, examine this file to make judgment calls on how to best reduce your code. Thank you for your time.